This is Cambridge IGCSE for Chemistry, Paper 6, Alternative to Practical, Variant 2, from February-March 2020. Question number 1. The table gives the boiling points of 4 alcohols, which are methanol, ethanol, propane 1-ol, and butane 1-ol. The apparatus shown can be used to separate a mixture of the 4 alcohols shown in the table. A. Name the apparatus labeled A and B. So A is a thermometer, and B is a flask. Specifically, it's a round bottom flask. Moving on to question B. Add to the diagram one arrow to show where water enters the condenser. So water enters the condenser from the bottom. Moving on to C. 1. Why is it not safe to heat the mixture of alcohols using a Bunsen burner? That's dangerous, as alcohols are flammable. You don't want to burn the lab, don't you? 2. Suggest how the mixture of alcohols can be heated safely. So in terms of like moderate warming, right, you should use a water bath, or maybe you can try to use what do you call it, a heating mantle, okay, instead of using a Bunsen burner. Right, moving on to D. Describe how the condenser allows the alcohol to be collected as a liquid. So you see, this is distillation. Distillation has 2 parts. The first part is boiling. The second part is condensation. How can the condensation happen? It's by cooling down using cold water passing through the condenser, and hence it cools down the liquid. So it cools down the alcohol or the vapor. Right. E. Which alcohol will be collected first? Explain your answer. Now, the principles of distillation tells you that the separation is based on boiling points of the substances. Now, you are doing heating in this experiment. The temperature of this mixture gradually rises from a lower temperature, then it reaches 65, it reaches 79, it reaches 97, and then it reaches 107 T. So once the mixture is heated to 65 degrees Celsius, methanol will start to boil. All right, then only the rest once the mixture is hot enough. So methanol will come out first, as it has the lowest boiling point. Right, moving on to the next question. 2. A student investigated the time taken to collect 40 cm³ of hydrogen gas when magnesium reacts with dilute sulfuric acid. 5 experiments were done using the apparatus shown. Experiment 1. Using a measuring cylinder, 8 cm³ of dilute sulfuric acid was poured into the boiling tube. Using a second measuring cylinder, 12 cm³ of distilled water was added to the acid in the boiling tube. The apparatus was set up as shown in the diagram, ensuring the inverted measuring cylinder was full of water. The bung was removed from the boiling tube. A coiled length of magnesium ribbon was added to the boiling tube. The bung was immediately replaced and the timer started. The time taken for 40 cm³ of gas to be collected was measured. The student felt the outside of the boiling tube. A1. The student noticed that the boiling tube was warm. What does this tell you about the type of reaction? So it will be exothermic, as exothermic reactions feel warm. 2. Describe one change that could be made to the apparatus to help keep the temperature of the contents of the boiling tube constant during the reaction. So in order to maintain a relatively constant temperature, it's best to use a water bath. Right? So let's look at experiment 2. The boiling tube was rinsed out with distilled water. Experiment 1 was repeated using 10 cm cube of dilute sulfuric acid and 10 cm cube of distilled water. So experiment 2 was repeated using 12 cm cube of this dilute sulfuric acid and 8 cm cube of distilled water. Experiment 2 was repeated using 16 cubic centimeters of dilute sulfuric acid and 4 cubic centimeters of distilled water. And experiment 2 was repeated using 20 cubic centimeters of dilute sulfuric acid and no distilled water. So what is going on in the experiments? It's a dilution process. The total amount of the solution is 20 cm cube with different volumes of sulfuric acid and also distilled water. So experiment 1 has 8 and 12. Experiment 2 has 10 and 10. Experiment 3 has 12 and 8. Experiment 4 has 16 and 4. And experiment 5 has 20 and no distilled water. All right, just a rough sketch. You don't have to write this in your exams actually. I draw this for us to understand this question slightly better before we move on to the table. Now, B, use the information in the description of the experiments and the timer diagrams to complete the table. Record the time in seconds. So the first part of the question asks for volume of distilled water. Actually, we literally just got that from the text, which is 12, 10, 8, 4, and 0 for each of the experiments. Then, based on the timer diagram, it's in seconds. So make sure you convert the values to second. Let's look at the timer diagram. For the first question, it is 1 minute and 12 seconds. So that will be 60 plus 12 gives you 72. Second question, it is 0 minutes and 45 seconds. So that will be just 45 seconds. For the third question, 0 minutes. And then this one is 33 seconds. And then the next question, that would be 23 seconds. And then the last question will be 16 seconds. Right, so how are the 4 marks awarded to you? The volume of distilled water measured correctly, there will be 1 mark. The second mark is, and the third mark actually, is the timer. Right, and then the time collected in seconds, there will be the last mark. Now, C. Add a suitable scale to the y-axis and plot the results from experiment 1 to 5 on the grid. Draw a smooth line graph. So it's about the time to collect 40 cm cube of gas in seconds versus volume of dilute sulfuric acid in cm cube. So I will suggest students to plot down the coordinates first, right? To jot down the coordinates first. So it's about the volume of dilute sulfuric acid, that's your x-axis, and the time to collect 40 cm cube of gas as your y-axis. So what are the coordinates here? 872, 1045, 1233, and finally 1623 and 2016. All right, so you can copy and paste this to the next page. Okay, I'm just gonna take the whole thing and copy and pasting it to the next page. All right, so we have the readings ready, although looks slightly awkward, but okay, it works. Now, as we can see, the y-axis range is from 16 to 72. So I will suggest students to use a multiple of 5 or multiple of 10 or multiple of 20. So I got a feeling that we should be using a maximum to 80 from 0 to 80. So I will take each 10 small boxes representing 20 seconds so that it's easier for us to draw. Right? If you use multiple of 12 or multiple of 15, that will be kind of awkward to draw. It's not easy to draw that kind of graph. Right? So by having 20 each for 10 boxes, that will allow an easier time for us to draw. Okay, as long as it's able to cover over half of the graph paper. Right? So having that said, let's plot. Okay, first graph 8 to 72. Second is 10 to 45. Next is 12 to 33. Next is 16 to 23. And finally, it's 20 to 16. Let me double check everything. 8 to 72, 10 to 45, 12 to 33, 16 to 23, and then finally it's 20 to 16. Okay, cool. Now, all you need to do is draw a smooth line graph, and this will be a inversely proportional graph. It's not a straight line, it's a curve. Okay, I'm using my iPad. I'm very sorry that I can't make a great graph out of this. Let me draw it. Let me do it again so that it's better. Hopefully, nope. When life hits you hard, don't care and still work harder. And then you should be able to reach your destination. Let's go. Okay, so we got the graph, right? So D1, from your graph, deduce the time taken to collect 40 cm cube of gas if the experiment was repeated using 9 cm cube of dilute sulfuric acid. Show clearly on your grid how you work your answer. So it's the 9 cm cube of dilute sulfuric acid. So based on the graph, this is 9. We draw a dotted line, and that allow us to point it out. So it is about 57. Should be about 57. Right, so 57 seconds. Right, please don't draw real lines, okay, for this because it's only a reference. So you use dotted lines. Moving on to 2, what volume of distilled water would be needed if the experiment was repeated using 9 cm³ of dilute sulfuric acid? So that is not based on the graph, right? That is just literally, we said just now, the total volume of the setup is 20 cm³. So all you need to do is taking 20 minus 9, you get 11. So 11 cm³ of distilled water is needed in order to make the total volume as 20. E, the rate of reaction can be calculated using the equation shown. 1. Use this equation to calculate the rate of reaction in experiment 1. Give the units for the rate of reaction you have calculated. So let's do that. It is asking for experiment 1. In experiment 1, how much volume is collected? It's not exactly in the graph. It's actually the experiment's own variable, constant variable, which is we are trying to collect 40 cm³ of gases. Okay, make sure you identify the correct variables in this question. And then time taken to collect the gas in experiment 1 is 72 seconds. So the rate of reaction is equal to, punch these numbers into your calculator. So you should be able to get 0.5 recurring. So convert it to two decimal places, round it off, it will be 0.56. And the units will be cubic centimeters per second. All right, so 2. In which experiment, 1, 2, 3, 4, or 5, was the rate of reaction greatest? Based on the formula itself, you know that when rate of reaction increases, the time should be shorter. All right, so which one has the least time taken to complete the reaction, to complete the collection? That will be experiment 5. In fact, it makes sense, right? Because experiment 5 has the greatest concentration out of all of these setups. Moving on to F, why would measuring the volume of dilute sulfuric acid with a burette rather than a measuring cylinder would be an improvement? That will be due to burettes are more accurate than measuring cylinders. Right, for G, the magnesium starts to react with the dilute sulfuric acid as soon as it is added. Why does this decrease the accuracy of the investigation? Let's look at the setup. Okay. So the problem is when you add the magnesium into the acid, we will expect it to straight away react. And before you manage to put the cover on top of the test tube, some of the gases would have escaped. Right, unless you have like fast hands, which is kind of impossible, right? So some of the gases would have escaped, or you may say that some of the gases will not be collected before the bung is inserted. Moving on to 2, Describe one improvement that you could make to overcome this problem. Okay, so how can we solve this problem? Now, there's one type, which is you can just suspend the metal, all right, on a thread. There can be a solution, or you can use a partition container, as long as it makes sense to solve this particular problem, which is of gases escape. All right, moving on to 3. Solution J and solution K were analyzed. Test on solution J. Solution J was colorless. Solution J was divided into 3 portions in 3 test tubes. The first test tells you that universal indicator paper was dipped into the first portion of solution J, and then it turns red as an observation. So it will mean that it is extremely acidic, which is like pH 1. Test 2, a spatula measure of sodium carbonate was added to the second portion of solution J. The gas given off was tested. Efflorescence was seen, and the gas produced turned lime water milky. This is a keyword. Whenever you see the word term lime water milky, you should think of carbon dioxide gas. All right, test 3. 1 cm cube of dilute nitric acid and a few drops of aqueous silver nitrate were added to the third portion of solution J. The observations show that it forms a white precipitate. Whenever you see the word white precipitate as a result of silver ions in aqueous solutions, you should think of halides. And specifically for the halide that forms a white precipitate, that will be chloride. All right, because silver chloride is white in color. All right, we've analyzed the given observations already. Let's look at A. Use the observation from test 1 to suggest the pH of solution J. So it's 1, extremely acidic. B. Name the gas given off in test 2. That is actually carbon dioxide gas. And C. Identify solution J. So the acid contains chloride ions. That will be a hydrochloric acid. Or you may say this solution contains H plus ions, which is acidic ions, and chloride ions. All right, moving on to the next question. Test on solid K. Solid K was ammonium nitrate. Complete the expected observations. Solid K was dissolved in water to produce solution K. Solution K was divided into 2 equal portions. D. About 1 cm cube of dilute nitric acid and a few drops of aqueous barium nitrate were added to the first portion of solution K. What's the observation? Now, whenever you see the word barium, the keyword barium, you should think of sulfates, because barium reacts positively with sulfates to form a white precipitate, which is barium sulfate. Right? So, this solution doesn't contain any sulfate ions. Hence, it will be a negative test, which means there will be no change to the reaction. Moving on to E, 2 cm cube of aqueous sodium hydroxide was added to the second portion of solution K. The mixture was warmed and the gas given off was tested. So you see the word aqueous sodium hydroxide. you should think of cation test. So it's testing for the cation, which in this case, ammonium ion is present. So how does ammonium react with sodium hydroxide? You can refer back to your booklet for the experimental, what do you call it, experimental results. But hold on just a minute. This question also asks for warming of the mixture and testing the gas given off. So you see, ammonium reacts with sodium hydroxide. That actually forms ammonia. And when ammonia is formed, what is the test for ammonia? You can use a red litmus paper, and then the litmus paper turns blue due to ammonia's alkaline nature, basic nature. All right, moving on to the next question, which is question number 4. A black dye can be obtained from some plant roots. Plan an investigation to determine how many different colored substances are contained in a black dye obtained from plant roots. You must include how the results you obtain will tell you how many different colored substances are contained in a black dye. You have access to plant roots and all normal laboratory apparatus. Right, so let's identify some keywords first. You want to determine how many different colored substances are contained. So you should think of chromatography. The source is using a black dye from the plant roots. So what you need to do is first crush or grind the root. Okay, the general, more traditional method is to use a pestle and mortar. All right, and then with that, you obtain the extract, I would say. So you take the extract and put on a piece of chromatogram paper. Okay, put a drop. Right. So two, you can place liquid on the paper. Okay, of the what do you call it, extracted liquid from the paper. And then three is to immerse this into a solvent, suitable solvent. So place the paper oops, the level should not be above the drop, right? So then you can just say conduct the chromatography once the paper is placed into a suitable solvent. So chromatography is started. And then you will see once the solvent diffuses across the paper, you should see set of colors, right? So with that said, the number of colored spots represents the different chemical substances. Let me see if there's any point that I can add into this, because how many marks is this? This is 6 marks. We crush and grind the root, and then we use pestle and mortar. We use a chromatogram, and then we place the drop at the bottom of the paper, and then we place the paper into a suitable solvent, and then chromatography is conducted, and then number of color spot represents different chemical substances. I got a feeling that this question has very limited answers, unlike certain past year papers. Let me just look at the mark scheme real quick. The first mark is crush and grind the root. The second mark is using pestle and mortar. The third mark is using a suitable solvent. The fourth mark is conducting the chromatography by placing the paper into the suitable solvent. Oh, so that essentially already is 6 marks. And then finally, the number of chemical substances can be represented by the number of colored spots. So pretty much we have everything covered. All right, so this is the end of the discussion of this paper. Thank you for watching.